Uh, Good afternoon, everyone. I extend very warm welcome as on behalf of BMTPC to this webinar series. Today is the fourth in this webinar series, which we are organizing on innovative building materials and construction technologies and climate resilient buildings. Today is the fourth seminar. So far, we have held three webinars. And all of them were received very well, and I'm really thankful to all of you for attending them with great enthusiasm. I again welcome you all to this webinar, and today we have a very special guest with us, resource faculty from CEPT University, Professor Rajan Rawal, who is authority in the area of energy efficiency, decarbonization, environment-related issues. Before I get into formally introducing him to all of you, let me tell you that at present, through Pradhan Mantri Awas Yojana, Government of India is also running a submission called Technology Submission, and through the technology submission, we are promoting good construction practices, alternate building materials, innovative construction technologies, which can help in resource efficiency, energy efficiency, disaster resilience, and overall sustainability. Of late, you all have witnessed this year we had excessive rainfall. We are being visited by natural events like earthquakes, landslides, cloudbursts, as well as we have environment-related, events as well. Excessive heat wave, urban heat island effects, urban floods, and thermal comfort also is being talked about because the temperature, all of you know, the surface temperature has risen to more than 1.5 degrees Celsius, and so our objective under Pradhan Mantri Awas Yojana is that to make houses not only affordable but they should be thermally comfortable as well. Also, all of you might be knowing that India is committed to NDC's nationally determined contributions through Paris Agreement, and we need to reduce our greenhouse gas emission by 45%. By 2030, and all of you know that by 2070 we have a very ambitious goal of becoming a net zero country. And our sector, construction sector, is going to play the most important role because construction sector contributes around 30% to greenhouse gas emission. It takes away 40% of natural resources, and I think similar 40% of precious energy resource. So if we can introduce good practices and innovative alternate materials and strategies which can help us making our built environment comfortable, sustainable, ensuring better quality of living, then we can achieve the target envisaged in NDC. And also, as Honorable Prime Minister has given a clarion call of becoming developed nation by 2047, so it can contribute towards that as well. And so with this, let me also tell you that Professor Rawal, let me introduce him. And Professor Rawal, I have been interacting with him for last couple of years, and he's authority in the area of thermal comfort. Being professor, he explains complicated issues related with energy and thermal comfort, U value, and other things in a very simple to comprehend language. And I'm quite hopeful that you will enjoy today's lecture. And because this is a rare opportunity where we have an expert who is not only recognized nationally but also internationally. So please make full use of this opportunity, and whatever questions you have, if time permits, if Professor Rawal permits us, then we will take all the questions and answers once the lecture is over. And I cannot allow you to speak, but what you can do is you can write your questions in the message box, and then I will speak them. I will pose those questions to Professor Rawal, and I will request him to answer those questions. So with these words, it's my privilege and honor to introduce to all of you Professor Rawal. Professor Rajan Rawal is a professor at CEPT University. He is also a senior advisor at the Center of Advanced Research in Building Science and Energy, CEPT Research and Development Foundation. His current focus of work is on passive design strategies, net zero energy buildings and communities, urban microclimates, embodied carbon in buildings, personal thermal comfort systems, and practices of adaptive thermal comfort models. He is a member of various technical core committees of Bureau of Energy Efficiency, Ministry of Power. I still remember Professor Rawal wrote the newly published Energy Efficiency and Sustainability Building Code. A chapter was written by Professor Rawal, and he took our help also in that. And he's also member of National Building Code, which is being revised. It's a mammoth exercise being undertaken. And this year only we are, thinking of issuing new National Building Code, revised National Building Code. He's also into voluntary green building rating programs. Professor Rawal contributes to the International Energy Agency, EBC Annex 69 on low energy buildings and thermal comfort, and EBC Annex 87 on the performance of personalized environmental control systems. Professor Rawal served as a co-chair of the United Nations Environment Program, UNEP, Cool Coalition Passive Cooling Working Group. Professor Rawal led the Indian-US Joint Clean Energy R&D Center, Building Energy Efficiency Sector, and Indo-UK project on energy demand reduction. He has played a pivotal role in the Global Cooling Prize, an innovation competition that developed a climate-friendly residential cooling solution that can provide cooling for all without warming the planet. Professor Rajan Rawal was honored with fellow status by the American Society of Heating, Refrigerating and Air Conditioning Engineers, ASHRAE, in 2020, and he also has fellow status by the International Building Performance Simulation Association, IPSA, in 2021, the first Indian architect to receive such honor. So with this small brief, Professor Rawal, I welcome you for this lecture on, and the topic is From Body to Building, the Third Skin and Building Science. Over to you, Professor Rawal. And I also request all the participants to mute their mic so that you can listen to him hassle-free. Thank you. Over to you, Professor Rawal.
Thank you, Shailesh. It's always a pleasure to be on BMTPC platform, and also more pleasure because the topic which I'm working since many years is what has been chosen as a webinar number 4. So what I'll do, I hope my screen is visible. What I'll do is that initial slides, I'll try to explain the thermal comfort. If anyone has any question, and if you use the chat pane, just type it down whenever you have a question. I will try to read that while I'm speaking, and if possible, I'll try to address right there. Otherwise, later on during the question and answer sessions. But don't unmute, just type it down. Thank you. What I'll do is that try to explain the thermal comfort, and some of you might have come across some of my slides or webinars, and I try to use this just to try to explain that why human beings sort of evolved species are different from rest of the flora fauna. You see a kind of colors, kind of diversity which you generally see across, but somehow Homo sapiens are having a little bit better way of doing a thermoregulation. Not only just our mind has evolved a lot and we have progressed a lot, but physiologically also we have evolved. And when I say physiologically we have evolved, we have developed additional capability to reject the heat from our body through perspiration. So you might not have seen any other animal who perspires, but humans perspire. And that's the evaporation which we use to remove the body heat from our body. You might have seen a horse perspiring a little bit, but not as much as what we do. Another way of understanding it that you might have seen a crow or a dog sitting outside in a shade, keeping the beak open and tongue out and breathing very quickly. That's the way they try to reject the heat, and they have to use their tongue because tongue is one of the best element in our body to do a heat transfer. I mean, the moment you sip hot tea, immediately you will realize that how sensitive that is, and it's sensitive primarily because it has a higher ability to reject or absorb the heat. And hence some of these animals also use open mouth and tongue to do a heat transfer with the immediate outside air. Um, very similar to our Earth, we also we have to maintain our body temperature in a very narrow band. This is more easily understood nowadays because you know that the way climate change is taking place and the way rising temperatures are creating havoc. Even 0.2, even 0.3 degrees centigrade in an average has created a lot of climate crisis on the earth. Uh, our body is also has to be remain in a very narrow temperature band. You know, the moment temperature goes up, you will feel like feverish, or sometimes it is more than that, which I'll explain in a while. So core body temperature needs to be maintained at about 37 degrees centigrade. And hence the skin needs to be maintained at about 34 degrees centigrade. It's a simple second law of thermodynamics that if heat has to get rejected out or it's been transferred somewhere, the other side needs to have a lower temperature. So the moment you have a skin, which is about 34, 37 degree will start transferring the heat out. And the 34, when you have room temperature, which is about 27 or 29, again, that air will start picking up the heat from the skin. If you try to put your room temperature much below 27, obviously there would be higher heat transfer values, but that means you are also draining your calories out unnecessarily. You are putting your body heat outside. And if you're using some of these the smart gadgets or smart watches, it does give you a body battery as an indicator. If you just experiment with your body that if you remain in a 20 degree centigrade temperature all across the year, you will lose a body battery very quickly. That's an easy way to understand how our body temperature needs to be maintained at 37, and hence the immediate room environment could be around 27, 29. If you don't do that, obviously you will have a certain kind of fever. We call it prexia or hyperprexia. When you go beyond 37 degree, when you go below, it's a hypothermia, and that leads to certain kind of cardiac or respiratory functions problems. If you go higher side, it will damage the cell. Not necessarily that our entire body remains in a same steady state. Uh, if your ambient temperature is about 30 degree, as you can see on the left side, your body would try to remain more or less in the same temperature range. But the moment you go to the 20 degree centigrade, some of the elements, some of the parts of your body will cool down just to maintain the core body temperature at about 37. So hands and legs will start sacrificing their their skin temperature to maintain the core body temperature. And also this is where the temperature inside our brain needs to be again maintained close to about 37, because that's where all functions are getting governed with. If you don't do that, immediately what will happen is that heart rate will go up, and then psychologically you will start losing the concentration. You may feel a little bit more irritated, and if the things goes beyond the control, the vomit is one of the best way which we can throw out our body heat out. If you cannot do that through the skin, all the or the food which you have taken up will come out through the vomiting, and you might be able to reduce your core body temperature. Beyond that, obviously, could be fatal, and needs to be maintained very, very quickly. Now, if I before I go into, okay, let me explain. To maintain our core body temperature, we do use various kind of mechanical and electrical systems, whether it's cooling or heating, and all of them do cost an energy. Energy will have impact on environment, and so on and so forth. So nowadays, the access to thermal comfort has become a challenge. Not that everybody have an equal access to the cool environment, or I would say comfortable environment. And hence, at the nation, when you start building buildings, whether it's a Prime Minister Awas Yojana houses, or you are building any other institutional building, the thermal comfort has become a priority. And it has been taken very, very seriously by BMTPC as well as some other government agencies. What is very important is that generally people say that, okay, if the buildings are uncomfortable, we'll put an air conditioner in it and we will be able to manage the temperatures. But you know that air conditioner will consume not just electricity. Yesterday there was ozone day. A lot of posts have come out that, okay, ozone layer is now coming back to its original, but still we have a long way to go. So kind of refrigerants which we use in a cooling system also damage the environment, have a very high, we call it a GWP, that is global warming potential, in those refrigerants, which also harms the environment. So it's not just about electricity and CO2, but many other gases which comes out of the production, or sometimes leakage of the cooling devices are need to be taken care of. So the way we generally explain is that it is always better to invest into buildings for long term. We always say that lock-in period for building is about 70, 80 years. If you go wrong in a decision making for cooling, or if you go wrong in a decision making for light bulbs, you might have an opportunity in 5-7 years to change that and correct your mistake. But if you make a mistake in a building, probably you will get locked in for about 70, 80 years before you start changing your building, or before you start reconstructing or retrofitting your building. So it's always important economically also that we keep investing ourselves into better building design and construction, and more so nowadays, not just in design and construction, which is also operational part of that. Some of the numbers which you might have seen in earlier webinars, that again, urban and rural population is going to go up. What is very, very alarming now is that throughout the coastal belt, either you start from Bhuj in Kutch to Jamnagar to Surat to Mumbai to Goa, right on the Kerala coast, or then you move towards Tamil Nadu. Lot of cities which are located in a coastal area are also going to not just going to face a humidity, but also not just about air temperature rise, but also high humidity. And this is where I think Shaileshji mentioned about heat stress. And I'll try to explain you later what is the difference between thermal comfort and heat stress. But heat stress is where the physiologically functions are getting compromised and productivity goes down. And this is what is happening, that over the years, we are getting more and more hotter days, not just hot days, but also length of the day. I mean, spells of the day. Earlier time, we used to get about 40, 42 degree about a week or so. Now 42 degree remains for about 20 days in many parts of the country, going up to about 45, 47 for a couple of days. And that is where it is not just about the peak, but the consistently peak is getting longer and longer in terms of days. So let's try to understand what's the thermal comfort. We try to understand thermal comfort with the 4 environmental parameters and 2 personal parameters. These environmental parameters are air temperature, relative humidity, air velocity, and mean radiant temperature. I'll explain them in a while. And 2 are other parameters, which is personal parameter, which is metabolic rate and clothing value. So amount of insulation you have it on your body. Other than that, acclimatization, short-term physiological adjustments. That means if you have moved from one city to another city, probably for a weekend or for a 7 or 8 days, you might acclimatize that as a short-term physiological adjustment. But if you spend about a year or more in any city, for example, somebody going from Jaipur to Chennai, it might take about a year for that person to get acclimatized with the high humidity, or vice versa. Someone who comes from southern India to Rajasthan also needs acclimatization for a lower relative humidity. Those other things matters. The body shape and a fat. BMI definitely makes a big difference. The higher the fat, lesser the ability to push the heat out, and hence one needs to sweat more and more to push the body heat out through the fat. Age and gender, definitely a male and female have a different kind of sensitivity towards the heat. While somebody ages, the adaptability or adaptive behavior reduces. Some at a younger age, you might be able to tolerate a wide band of temperature, let's say 18 degree to about 46 degree. But when you grow older, probably that reduces to about 25 to 40, 15 degree would be a band. So that means ability to adapt the cold and also adapt the hot side when you grow old becomes less and less and becomes challenging. And sometimes the status of health, if someone is under impression of any medicines or even alcohol, that also affects the thermal sensation and thermal comfort. But these are the things which we really don't consider when we design a policy or design a building. We try to focus a little bit more on these 4+2. These four, at the same time, as I mentioned, that your body does not remain in a same temperature range across the body, where the forehead and top part of the body try to remain in a more or less plus minus 34, 36, versus a foot and calf, as you can see here on the right hand side, has a huge range about 10 degree or even sometimes 12 degrees centigrade. So if you're in a neutral temperature about 27, your forehead would be about 35, may deviate to about 31 if you go for a lower side, may go up to about 2 degree if you have a higher temperature outside. So basically it deals with the delta of about 4, 5 or 6. But if you see right at the bottom, the foot has a delta of about 13 degree. And that's where the ability of humans to adapt immediate outdoor and immediate indoor and outdoor both environment makes us a little bit more different from rest of the thing. So we have a high adaptability, as you can see here. A range of temperature can be adapted. Now, problem is that when anyone starts exposing themselves with a constantly narrow band of temperature, for example, if I start remaining in a temperature band of 24, 27 all the time, 24/7, in an air-conditioned environment at office, in air-conditioned environment in a transport like my car or aircrafts or public transport, or air-conditioned environment in my own home, bedrooms or even living rooms, constant exposure to the narrow band of temperature will reduce our adaptability over a period of time. And hence, then we have to seek only 25, 27 degrees centigrade with a 50% RH all the time. So even for human survival, even for reducing the heat stress, it is very, very important that we keep exposing ourselves to higher temperatures and lower temperatures as and when required consistently. It's not just about I will go to Switzerland once a year or I will go to Jaisalmer once a year. Consistently, every day one has to expose itself with the higher temperatures as well as the lower temperatures to maintain whatever is their design in our body. Coming to those 4 environmental parameters, air temperature, many of you know what is it, measured in a degree centigrade. Relative humidity, and now this is becoming more and more crucial nowadays because more vapor is available in the air while all that ice and all that glaciers are melting is not just turning into water, but high temperature also turning that water into water vapor at some point in time. And hence the high humidity across the world has taken attention of many people who is working in this area. Relative humidity, while we say it's basically amount of vapor in an air. Now, many of you might know that if you have a air at high temperature, it can absorb more vapor, versus if air is at a lower temperature, it can absorb lesser vapor. So you see on the extreme left hand side, if I have an air molecule which is about 30 degrees centigrade, and water vapor is about 28% in that, my relative humidity would be 28%. But same amount of vapor with the red dot which you see, if you take it down to about 10 degrees centigrade, the entire air molecule would be filled up with the vapor. That means very high humidity. That means there is no additional space for a vapor to get in. It's 100% saturated air, and it will start condensing if it is at 10 degrees centigrade. What is happening is that our ability to lose heat reduces when you have a high humidity outside. You might have experienced it if it is a onset of a summer, which is April, May. It is easier to reduce or easier to get a comfort if you go in a shade or you take a glass of water or buttermilk. But towards the monsoon side, when temperature remains high, when humidity remains high, people start very uncomfortable situation. And actually that gets translated into the market trends. Also, the sales of room air conditioner picks up more near to the monsoon than onset of the summertime. Along with that, very important element, which is mean radiant temperature. So you might have observed that your room is at the lower temperature as a comfortable, but because the walls and roof are high temperature, they're warmer, you feel a little bit more warmer. This is where our human body works with immediate, I call it a third skin, which is a building skin, is that if the temperature of a surface temperature of a wall and roof are higher, air temperature is lower, still you will not be able to feel comfortable. Many of us have experienced this in when you travel in a air-conditioned bus coaches, or you travel in a cars with the air conditioner inside, but if solar radiation is hitting your window pane or windscreen, you will still feel very uncomfortable. Indoor temperature maybe you may set it to about 18 degree or even 20 degree, but constant radiation hitting your skin will make you very uncomfortable. And that is where the mean radiant temperature comes into it. This parameter has highest impact on our human body because it interacts with the skin permanently. Even if you are wearing clothes or even a blanket, sometimes the infrared radiations do exchange. Air velocity, we have very well understood. The moment you start a ceiling fan or a pedestal fan, or if your windows are open and you get a breeze inside your house, you will start feeling more comfortable. This is primarily because the air which is touching your skin is taking the hot temperature, so a higher skin temperature gets absorbed in the air and air moves on. So basically in a thermodynamic, we call it a convection, that because of the high convection, you are losing the body heat. So if you are feeling very uncomfortable towards warmer side, you get inside the room. The moment you start ceiling fan, your body will start losing the heat in a much better manner, and hence the air will pick up the heat and will move forward. So that's where the air velocity becomes more important. Obviously, the clothing, what you are wearing, if you're just wearing a swimsuit or a cotton t-shirt, half sleeves, you will feel a little bit more comfortable, versus three-piece suit will make you uncomfortable because the clothes are also an insulation on top of our skin. So the way we explain is that Skin, what we got is a biological skin from the nature. The second skin, that's the first skin. The second skin is what we wear, which is clothes. And third skin is what the buildings are. And if these three don't interact with each other, if we don't understand these three all together, we might not be able to solve the kind of problems which we are trying. And sixth one is the metabolic rate. So if somebody is gymming, definitely the person is burning a lot of calorie in their body. That calorie generates the heat. That heat needs to go out. So in an average, if person is at a sedentary position, so for example, if you're writing or if you're typing on a computer, you might generate about 60 watts of energy, 65 watts of energy. And a normal adult, which has about 1.7 square meter of skin area. But if you are gymming, obviously you can emit up to about 180 or sometimes 200 watts of energy. While you sleep, it goes down to about 40 or 45. So the amount of body heat you generate needs to be taken out of the building. And buildings are not really designed to do that, and hence many times we use air conditioner, especially in the areas where the heavy workout or heavy activity is taking place. Now I know that many people will also talk about the quality of air in the gyms or quality of air in auditoriums where you have a lot of people, but we are right now not talking about environmental quality of there. We are just focusing on the thermal side of the or thermal comfort side of the body. So what is the definition? Definition is that it's a condition of mind that expresses the satisfaction with the immediate thermal environment, and it's basically measured through the subjective evaluation. Now, this is one of those rare scientific definition accepted across the world, which doesn't have numbers, and it doesn't talk about any particular formula. It says that it's a subjective evaluation. That means it is a vote. So if somebody has to say that what is your BMI, the body mass index will have certain kind of formula and said, okay, per person would be X and Y and so on and so forth. But here it is more like a vote, where it says, yes, I'm comfortable or I'm not comfortable. Now, when I say I'm not comfortable, it has two dimensions to it. But before that, let me explain that our thermal sensation do change depending upon where we are. Psychologically, that makes a lot of impact on us. So what we try to do is that the way you perceive thermal comfort, the way you want to have a thermal comfort in a 5-star hotel or in a cinema theater, you do not expect same kind of thermal comfort when you go to vegetable market, because psychologically you know that the vegetable market is naturally ventilated building and it cannot provide you same kind of cooling or comfort which you generally expect in a star hotels or in the aircrafts or in the airports or even at the cinema theaters. So because our mind is very closely monitoring what's the skin temperature is, it has a psychological and a behavioral impact. And hence, it is more like a vote than an absolute value. So when you are in a naturally ventilated building, when you are air-conditioned buildings, you have a different kind of opinion about thermal comfort. So what is naturally ventilated building? Basically a building where you can open windows, you have no active mechanical cooling, you still may have about ceiling fans, but you are not compressing the air or you're not changing the property of air beyond the air velocity. They are called a naturally ventilated building. Mixed mode buildings are somewhere in between. They do use air conditioner at some point in time, but they do not use air conditioning in other point in time. For example, many of our residences, where in a summertime, summer nighttime, bedrooms becomes air conditioned, but rest of the time, rest of the house will not be air conditioned, or same bedroom does not get conditioned during the winter time. So there are various kind of, or rather subtypes of mixed mode building, we call it. Some of them are spatial mixed mode, some of that temporal mixed mode. And third one is a concurrent mixed mode. Concurrent mixed mode is very similar to what our wedding shamiana or book fair or automobile trade fair looks like, where your windows are open but air conditioning is also running. So it's a concurrent mode where air conditioning is running, window is open or doors are open, and you are trying to get a thermal comfort. And air conditioned buildings are generally a sealed buildings, use of compressors, use of air conditioners, and most of the time it gets operated when there is an occupancy. So this is what I was talking about earlier, that any kind of thermal comfort get assessed through these four votes. And when I say vote, is it's not a value, but it's simply an opinion. So for example, four parameters: one is sensation, one is acceptance, one is preference, and satisfaction. And I'll talk about that in a while. So when I say that, if I ask someone that, are you thermally comfortable, that depends upon what that person is saying about its sensation. So the way to ask is that, are you feeling hot, or are you feeling cold, or you are feeling neutral? So that is what we call it a sensation. What is your sensation at this point in time? But that sensation is not enough for us to judge whether the person is comfortable or not. We also would like to know the acceptance. Sometimes you feel warm, but you want to feel warm after coming from very, very cold area. And if the warm immediate environment is acceptable to you, then it's fine. So that comes to a preference. So that means, are you comfortable? You say, no, I'm feeling a little warm. That means that's a sensation. Is that acceptable to you? I would say, no, it is not acceptable to me. Then the third question comes that, okay, if it is not acceptable, what do you prefer? And then people say that, okay, I prefer a little more cooler environment. And these three things comes together and tells us that whether person is comfortable or not. Now, why do we really need to look at these three things before we say that person is comfortable or not comfortable? Is because the aspiration also comes in the picture. And this is sort of worrisome condition or worrisome context for people like us who work in this area. Largely the Indian population, if you ask people, and let me go to the next slide. Yeah. If you ask people that, what's your sensation vote? And they say, oh, I'm feeling comfortable. I'm fine. I'm just okay. Then if you ask that, oh, is that acceptable to you? They will say, yes, it is acceptable to me. I don't need, I'm fine. But when you say, what do you want to be? If given a chance, if you want to change your condition, I would say 90% of the population in India say, we want to be cooler. And this is where the aspiration of the person comes in the picture, that I am feeling comfortable and I'm okay with that. But if you can give me, I would like to be cooler. Now that is where you are paying a penalty on environment. You are not just on environment, on economics, but you're also putting a penalty on your own body, where you know that your body could be comfortable at 27 degree or 29 degree, but you still want it to be 21 degree. That means you are putting your body into certain kind of thermal stress, and hence you will spend some more calories to keep your core body temperature as 37. And that means that you would require more calories to get into your body, hence you will eat more, and hence so and so forth. So basically it's a downward spiral which we get into, that conditions are good enough for us to operate, but given a chance we want to be cooler, and that means a whole lot of other things, as I explained. And that's bit of concern for many of us. So when you put all these 6 parameters, the air temperature, radiant temperature, and velocity all together, and if person says that I'm comfortable, that means it is neutral, and that is what we call it. 100% people are satisfied, but it is very, very unlikely that any building, all 100 people 100% people are 100% satisfied. That means we have to have a certain kind of band under which we, for whatever reason, whether it is a BMI or because somebody has migrated from somewhere or somebody is under health conditions or which is different than the rest of the people, or because somebody is wearing some different kind of clothes, they might feel uncomfortable towards warmer side. So what generally we try to provide a guidance to the people is that try to put 20% people dissatisfied. So we call it a percentage people dissatisfied, PPD. So if you if you look at this graph, which is a inward a bell curve, where if you move towards a slightly warm or you move towards slightly cool, the vote is +1 or -1. The moment you hit about close to about +1, you will feel about 20% people are not going to get satisfied with the and then we said, okay, this okay, it's fine. 80% people are comfortable, and that is what all building can target and to achieve. What is the impact of that on the policy? The Eco-Niwas Samhita, which is residential code, which relies on residential envelope transference value, RETV, has taken up these kind of conditions and that, okay, our houses should not become hot and there has to be some degree of comfort. Hence, they have adopted something called degree discomfort or discomfort degree hours. That means in that particular house, the way they constructed, design and construction both, the degree discomfort hours should be less than X amount. And if you read that, you will find what is this X meaning to. The same thing has been adopted in a national building code that looking at a very diversity of our country from Meghalaya and Arunachal Pradesh to Rajasthan and Gujarat, from Jammu and Kashmir, Ladakh to Maharashtra, Nagpur, Vidarbha, and Kerala. It's very difficult for people to come to a one value which is acceptable to all Indian population. So National Building Code and then Energy Conservation Building Code from Bureau of Energy Efficiency, what it says is that we don't prescribe a value. We prescribe a band of value. That means if you are within this range, you should be good enough. And that range could change depending upon where you are located. So sometimes it may happen that people coming from a hotter environment would like to keep the higher temperatures, and people coming from cooler environment would like to keep their but for building designer, it's important that they don't need to hit a value. It is a band under which they have to start playing around with. If we try to understand physiologically what is people have, this is in 1930 people have started looking at it as how much amount of heat you produce, what's your skin, what's your sweat, what's your clothing, and how much heat you will be able to reduce. So this, we call it a heat balance in any kind of physics, or even in accountancy. We have these profit and loss balance account. So amount of income and amount of expenditure, if becomes 0, you don't need to worry about. And hence same thing happens here, that if amount of heat which you generate, if you can put that heat out of your body, you are comfortable. So that's what that's what the concept people follow here, that how do you produce heat? You produce through metabolism, you gain some conduction, convection, radiation, you shiver, and you also lose the heat from evaporation, which is, I say, the perspiration. And if you hold a warm cup of coffee, that's a conduction. If you sit in a open air or on the seaside, it is a radiation. And when you switch on the ceiling fan or fan, it's basically convection. That's how you also lose the heat. And when you balance between these two, you will be good enough, you will be comfortable. And there's some equations which I'll not get into the detail, but what I'm trying to explain here is that body also stores some kind of heat over a period of time, and that needs to be accounted. So When I move from very hot environment from outside and when I get into very cool environment, it does take a little bit of time for us to adapt. And this is where the body is stored, the heat which is stored inside body also needs to be released over a period of time. Now, at this point, I mean, what's the next one? Okay, let me explain this and then go on to the heat stress side. Now, there are the equation, which is physics-based equation, had a lot of limitation. And this was getting practiced until 1990. But then 1995 onwards, all of us have realized that it is not our body is not like a physics. It's not like a machine. We have a mind. We have a certain kind of aspirations. We have feelings. So it's not just about a physiology, but psychology and behavior also starts playing a role. And the newer the codes and newer the guidelines on what BMTPC follows is based on something we call it adaptive thermal comfort model. That means that, as I mentioned earlier, that when you go to a vegetable market, you know that vegetable market cannot provide you 22 degrees centigrade and you accept it. That's where the psychology works. When you are coming from outside to inside and you feel that, oh, it's a warm or it's a hot or it's a cold, you don't really start cribbing. You wait for about 10 minutes, 15 minutes before you start feeling comfortable. And that's where the psychology comes in the picture. Second is a behavior. When you are allowed to change your clothing, when you're allowed to change your position. So we have seen multiple times in cinema theaters that people take shawl with them, and then the middle of the movie they will wear the shawl. Now this is where the behavior comes into the picture. You are allowed to behave in a certain manner, and moment you allow people to behave in certain manner, they would be more comfortable because that's very directly related with psychological aspects of that. So all newer work and the newer policy which government of India is following is based on this adaptive model, where you, your building also needs to sort of respond to multiple directions. So let's try to talk about this where the building, which is the third skin, comes into the picture. So just focus on the right hand side for a while. There's something called mean radiant temperature asymmetry. Basically, we are talking about temperature, air temperature difference and surface temperature difference. So if your surface is warmer than air, what happens? So let's say if you have a ceiling which is warmer by about 15 degrees centigrade, you are likely to have about 40% people dissatisfied. So that means that my ceiling is very, very important, and any change in a ceiling temperature affects people much quicker and widely. Versus if I have a cool wall, same 15-degree asymmetry, but cool wall will make about 20% people dissatisfied. If I have a cool ceiling, I will make probably about 8% people dissatisfied. And when I have a warm wall, I'll make about 2% or 3% people dissatisfied. Now, what does it mean? As a building designer or someone who constructs the building or someone who manages the building, the learning here is that if I have a 5 rupees or if I have 10 rupees to improve my building, I will put that 10 rupees on my ceiling. I'll try to reduce a surface temperature of my ceiling. Then if I get, let's say that ceiling is done in 8 rupees, then probably I'll put another 2 rupees so that my wall does not become very cool. Then I will probably try to do with some kind of cool ceiling, and then I'll try to do with a warm wall. So this is how the body behaves with this immediate surrounding, because exposure of the skin or body part to warm wall and warm ceiling is different. Because if I'm talking about ceiling, just my head is directly exposed to ceiling along with my 2 shoulders. But if I'm talking about wall, a lot of exposure I have, entire body is exposed to the wall. So these other things matters over a period of time. Same if you have a floor temperature which is about 35 degree plus, you will feel a lot of people unsatisfied. But if you take down floor temperature about 20, less than 25, people would come. So carpets in a cold areas or in northern India have become a very, very effective way of managing your temperature, because that gives you an insulation. Now, same floor, when you move towards the Karnataka or move towards Tamil Nadu or even Kerala, the use of stone becomes very, very important, because that gives you a cooler surfaces on the floor, and you feel more comfortable with the floor having less than 25 degrees centigrade. It's also important that within the body, we should not have a temperature variation more than about 3 or to 4 degree. As you can see that if my feet are warmer, or difference between feet and head is about 8 degree, a lot of people will feel uncomfortable. Where I reduce that to about 3 degree, less than 10% people would be comfortable. There's someone's microphone is on. If I request them to keep it on mute, please. So this is where the third skin, which is where the physics comes into the picture. Whether it is an earlier time, whether it is old times where we used to make huts, or in the future when we'll move to Mars and we'll move to Moon, and when we'll try to make our houses there, the building skin is going to play a major role. We still will be able to manage our body temperatures and our clothing, but if the third skin is not helping us, the first two skin will start struggling a lot. There are various ways by which you can manage your heat transfer depending upon which climate zone you are in. The Energy Conservation Building Code and National Building Code has recognized 5 climate zones, and depending upon which climate zone you are working or you are designing your house, it gives you an understanding that should you give importance to wall, should you give importance to roof, or fenestration, which is windows, and so on and so forth. Now, 2 ways you can manage these things. One is the design wise, and one is material and construction wise. I'll focus a little bit more on material and construction because that's what the focus of BMTPC is. There are a whole lot of other design features are possible, but materials methods are quite important. So some materials which has ability to reject the heat, which is insulation materials, like EPS and XPS. There are some materials which has ability to store the heat, like stone or bricks, and they store heat, and depending upon the temperature variation, they release the heat. Both of them are helpful. There's some point in time people said, oh, we should do insulation. Insulation is also helpful, but thermal mass, which stores the heat, is also very, very helpful. So when you want to, when you are in extreme conditions, where you cannot open the window at all, and India doesn't have any of those situations, even in Ladakh. I mean, I'm talking about non-armed forces conditions. So if you're in Ladakh, you would like to have a thermal mass a little bit, where you can capture the warmth during the daytime, and you can use that warmth in the nighttime if you are making your building out of stone. But at the same time, insulation is important because that's where you know to reject the heat right away. This is the way we try to understand the heavily industrial material. For example, if somebody is doing a building in an area where land cost is very, very high, obviously the carpet area is going to sell, and that's where the economics make sense. So instead of going for 200 mm thick brick wall, one might go for a thinner wall with the insulation. So what you're seeing here is that overall thermal transmittance value, we call it the U value of all these, what you see on the screen, is 0.4. I can achieve this 0.4 with a 200 mm brick wall, or I can achieve that with the 80 mm of XPS, or I can achieve that with the 60 mm of polyurethane foam, or sometimes 10 mm vacuum FRG as well. So, but if you are building something in a rural area where land cost is not going to get high, you have a challenge of accessing insulation or construction. People will not be able to manage insulation on wall. Obviously, you can go for vernacular material which are available in nearby area. So when people say that no, insulation is must, I'm saying no, depending upon the situation, depending upon economics, you need to decide where you want to use what. However, it's also depend upon what kind of building which you are making. Are you making air conditioned building, or you are making a naturally ventilated or mixed mode buildings? So here, what I'm showing you here in the first, where insulation is outside, this is a very useful situation when you have a naturally ventilated building or you have a building which is mixed mode. So what you're seeing here is that if you can see my cursor, that my outdoor air temperature, which is red here, is, let's say, 35 or 37, but my surface temperature would be little high. I have put in insulation outside surface. That means my temperature gradient would be much lesser. Then my concrete comes, and then probably I'll be able to get somewhere around 27, 26 degree inside. This is very useful when I want to reject the heat right away. Versus if I put the insulation which is inside, which is the second one here. This is the condition which is very useful if I have a completely air conditioned building. That means whatever cools which I'm generating inside, I want to retain that, and I don't want it to warm up or cool my RCC or any kind of structural walls. Hence, I will put my insulation right inside. So most of the time, people have this question that should I put my insulation inside or should I put my insulation outside? So simple way of understanding is that if you're naturally ventilated or mixed mode buildings, you would not like to even warm up your walls. Hence, put the insulation right outside. If you are having air conditioned building, you want to retain the cool air within the room, put insulation right inside where the heat transfer is going to start with. So that's how you decide. BMTPC has done amazing amount of work in promoting innovation with the various kind of technologies. The PMAY is one story, and then their demonstration housing projects are another story, and their own work towards pushing innovation is sort of stories, and there are a couple of more other stories which you will be able to find. What we did is we helped people try to understand what are the U values, what are the overall thermal transfer values of these materials. So you have seen conventional brick wall versus you have something called reinforced EPS core, where you have an EPS core in the center, and then you start using that as your structural walls and so on and so forth. Sometimes you have PPGL, which has insulation inside, but at the same time metal cladding outside, or drywall construction. So a whole lot of detail you will be able to find from BMTPC website. What we did at my university, we started looking at them and said, let's test it out and let's start seeing them. How do they really perform? So as you can see here, that the brick wall, which is about 1.6, 1.63, which is a rat trap bond, the moment you start using insulation, obviously your U value, the overall thermal transmittance values starts coming down drastically. And that means that you will be able to achieve the Econeva-Samhita RETV values quite well. And this is where the insulation plays role. Immediately when we start doing very highly industrial work, industrial production like this, we also keep a same amount of importance to our vernacular practices. What people have studied or what people have practiced since many, many years in a various climatic zones, various geographical regions, whether it is a stabilized earth block, whether it's a water and dope construction, there's a rammed earth wall construction, even as latest as AAC blocks. How do these are functioning? So, and this is the values for that. So water and dope construction probably might not be able to get you about even 1, but it has a value when you really can't access the industrial material. When you start talking about embodied energy, probably there's an easier way to uh, uh, dispose of some of these materials. Industrial material needs to go through the cycle of industrial process. It's very similar to our glass bottles. Glass bottles are one of the best bottles which we can find to keep hygiene intact, the durability, longevity, but at the same time, we want to dispose of the glass, it needs to go back to factory. So it's all depends upon how are you looking at the life cycle assessment. Uh, and some of these technologies can be used in a rural area or in the buildings which are having a lower structural requirements and so on and so forth. So you will find some of these documents. I will share the links, and BMTPC website has this catalogs of materials as well as their thermal values and thermal transfer. Coming back to glass, yes, we would like to have a glass which is just a light transmittance and not a heat transmittance. You do see, you do get a, at the cost, definitely, the glass which has the ability to lower down the heat gains through the glass. So what you're seeing here is that from 300 nanometers to 2500 nanometer, if you use the clear glass, probably it might bring a lot of heat. But if you have a low emissivity glass with some kind of argon filling in its side or silver coating, it will bring a light, but it will not bring the heat inside. These needs to be used along with the double glaze units. They cannot be used as a single glazed units because of the coating also requires some kind of environmental protection from outside. So that's how we always try to, one has to balance between amount of light which you need and amount of heat you don't want to get in. There are some theoretical limits on physics based that certain things are possible to achieve, certain things are not possible to achieve. So, but it's always a catch-22 situation. If you lower down the solar heat gain, which you would like to have, then you will not get a high light transmittance. If you want high light transmittance, then the heat also will start coming in. So the selection of glass becomes very important. And last couple of slides on a cool roof, and then probably it's an hour of talking, I'll end. Cool roof are the ones which helps you to reduce the surface temperature of the roof. What they do is they reflect the sun during the day night, but at the same time, whatever heat gets stored in the body of the building material, it also puts it back. So we call it a sort of effect of emissivity. So when you say it's a white paint, it's white paint might be working during a daytime, but another point it has, another advantage it has, is that whatever gets stored inside the material also can go back into the air because the surface temperature of these paints or coatings or tiles remains lower also during the nighttime. There are three types of such things are available. Some of them are paints, some of them are coated sheet from factory. Paints are very useful, but at the same time, we have seen very good practices and I must say very bad practices of using paints also, because most of the time what people do is that simply they paint it without realizing what is a substrate. Paint sometimes does not behave very well with any kind of substrate. So that's also a very critical point here. Coated sheets are basically factory products, and tiles are also factory products which are available and helps you to do that. So there are two links here. Whatever I have spoken, everything is available on the website, on the webinars, and these documents. You will be able to access that. With that, probably I will end my talk and would be very happy to take questions or queries or even a discussion. Thank you.
Thank you, sir. Thank you. I think you can write your questions in the chat box if you want. So just to start the discussion, I have one question for you. Sir, as you know, we have been promoting precast concrete construction. And every now and then I'm being asked that concrete is not good as far as U value is concerned. Then another logic I'm being given that it has, since you make the building with concrete, it has thermal mass. So what's your take on thermal mass versus vis-a-vis insulation? Could you, could you, sir, could you hear me?
I could hear you. Okay. So sorry, I was on mute.
Okay.
So when I have a concrete which is higher than 200 millimeter of thickness, then I will consider that it has some storage capacity of, and hence I will call it a thermal mass. Of concrete which is of 100 mm does not have a thermal mass. It can't store heat. Now, when you use 100 mm of concrete, it is very advisable to put it along with the insulation, just to make sure that heat transfer gets reduced. But if you're making a concrete wall, which is 230 mm thick wall, then it itself will act as a insulation up to a certain extent. So it will boil. So this is what I always say, that there is nothing wrong and right with the material, but it's always good and bad practices. How are you using it? I mean, we have seen a whole lot of stories across the country. I may have best of the best car, which can run at 240 kilometers per hour. But how responsibly am I using it is where the problem, the thing comes in. Basically, it's boiled down to the practices, which when people start bashing the material, I feel very bad. Because they don't know how to use it, they're bashing it. There's nothing wrong with the material.
Okay. So another question related with technology is, you know about aluminum formwork, MAI-1, customized aluminum formwork. So 2008, when I joined BMTPC, we were promoting it, and today this is the most widely used technology in the country. So the first assignment given to me was, thermal comfort with respect to aluminum formwork, because you have 100 walls altogether, or 6 inches wall along with slab. So that time I did a detailed study, and I came to know that most of the heat, and you also showed in your presentation, that most of the heat comes from ceiling. So if we make a structure with customized formwork, shear walls, and a thicker slab, will that solve the problem of thermal comfort?
I feel that the walls, so see, if I have a ceiling which is cooler, definitely it is going to make an impact. But when I'm making a multi-story, multi-family houses, obviously my walls becomes more important. And when I have a smaller volume, wall becomes. So for technologies like MAI-1, only MAI-1 is not a solution. It needs to have a certain kind of insulation. So Shailesh, this is what generally I tell people, that when you have to make construction very quickly, you cannot rely on something which is traditional. You have to go for something like MAI-1. But if you stop at MAI-1, then it will be problem. You have to take MAI-1 to a level where it's thermally more comfortable. So there are two things. One is a speed of construction and one is a thermal comfort. For both, you need a two separate strategy. One, I mean, it's not like a silver bullet which will work everywhere.
Correct. So another question from my side, because I keep interacting with people and hold these webinars. So right now, what we are doing, because of resource efficiency, we are trying to bring in low carbon cement, in a sense that we are replacing up to 70% cement by some waste material like slag, fly ash, microsilica, silica fumes, and other things. So how do you rate these kind of concretes vis-a-vis, in the light of thermal comfort or U values?
So I think the admixtures don't really change the thermal character of the material. It's basically admixture. I mean, you can't have admixture 50%. Admixture is mixture. So
Yes.
Primarily, I think what makes difference is that, I mean, we don't really care if what's your admixture is, and primarily boils down to what is your core material.
So you mean to say the kind of cements we are, the kind of concrete we are using, where we are mixing fly ash or slag, will not help towards lowering down U value?
No, no.
Okay, that's a good answer. Yes, sir. So I think now there are two questions. One is from Mr. Patel. He is asking, I would like to hear from you that by using geopolymer, so nowadays we're talking about geopolymer concrete also, concrete without cement. So he's saying geopolymer mortar, which is fly ash plus GGBS, that is blast furnace slag, plus manufactured sand for plastering external surfaces for residential buildings. Is the thermal comfort achieved like in our areas where peak temperature in summer is more than 42 degrees Celsius?
So whatever I'm saying is based on my general knowledge and general understanding, is that any kind of plastering material will not change the thermal performance drastically, because the plastering material, that means you're talking about anything between 8 mm and 12 mm at the most, or maybe 15 mm. Now that small layer against 150, 120 mm of thickness would be negligible. So I don't think that it will make a significant difference at 40, 42 degrees centigrade in summer.
Thank you. I think you answers are very explicitly. Very nice. Another question is from Dr. Sunil Parik, our associate in ministry. He's asking what challenges are there in implementing such technologies in large scale affordable housing projects?
So Sunilji, I think Saileshji also will be able to share this with me, the sentiments which I have. So I think the one is that mobilization of market and mobilization of technologies and proven technologies. I think what is happening is that a lot of innovators are coming forward having a good technologies, but since there is no level playing field for all of them, people like Shaileshji struggle to figure it out that should I believe in this technology or not. So I think this technology assessment and a common platform for technology assessment. It is not that I will assess on my own and Pankajji will assess on his own. A common assessment framework will help policymakers decide that this is the thing which we need to do. This is the thing which we cannot do. Please improve on that. I think biggest challenge, apart from the supply chain management, apart from the cost, everything you put it aside. What is most important is that a single way, a single assessment framework for technology.
Wonderful, sir. Wonderful. So shall I take next question?
Please,
next
please.
is from Ayushi. All the things that we have discussed today are not being used extensively, probably because of lack of knowledge among architects and contractors. Is availability and cost an issue too? How can we make sure and do our part right? It's a good question.
So Ayushi, I think partially I have addressed this, that it probably cost and availability comes second. What comes first is a faith. Do I believe that by buying what am I buying, even at the premium cost, I don't mind spending. I mean, people have money. Large amount of people who are in urban area. I'm not talking about affordable housing, but a lot of people who can spend, but they don't spend and go for conventional practices because they don't have a faith. And why they don't have a faith, as I mentioned, is a technology assessment program. And second is that enough case studies. A lot of people, architects, do come across case studies which are just design case studies. But no case studies will talk about design, construction, and performance over a period of 1, 2, 3, 4, 5 years. Good magazines talks about only design, but they don't talk about performance. Performance can be measured only once you construct it. When somebody, I mean, as simple as that we go to any hotel or we go to a restaurant and ask for review. If you don't find any reviews of materials or schemes or something in a website. So I think faith comes before cost and availability issue.
Okay, sir. So the next is from Aditya. There are various materials widely available like WPC panels or wood plastic composite used extensively in walls and ceiling inside and outside of buildings. Does it make sense to consider such materials to breathe microplastic in the building envelope? Your expert insight shall enlighten us for design level.
So microplastics will not help in a thermal comfort. But when you start using microplastics, it has another disadvantage that it needs to remain in the system of the wall. If the microplastics gets out of the wall and gets into the environment, then we have a disaster. It's very similar to our blood, that if my blood keeps moving inside my body, there's no problem. But the moment it leaks out, it damages us.
Yes.
So I think problem with some of these admixtures and microplastics and other thing is that it should remain within the system and should not get out of the system.
Yes.
But thermally, it is not going to make any difference.
I think just to add to that, you only talk about VOCs, volatile organic compound. So if panel is within that safe limit of that will do.
Yeah.
So okay. There is another question. What about cavity walls and void slabs, hollow slabs?
They don't have a good thermal performance.
So I think, sir, is there any other question or somebody would like to ask? We give you 1 minute. Okay. There is another question from Sunil. Is there any way to make cost effective and improve the supply chain for its adoption by common mass? He's talking about technologies.
Sunilji, I'm not the best person to talk about supply chain, but I think what is very effective is the successful case studies. I mean, BMTPC has done a lot of work, and I'm always eating up Shaileshji's mind that you guys have done work. Can you tell me with a confidence that this work and this does not work? Now, person sitting in a government might not be able to do that, but somebody outside should be able to do that. I mean, we academics and a whole lot of other business people should be able to tell that this works and this don't work. So I think we need a very definitive answer towards the technology. And once we have that, the supply chain problem would be solved.
Okay. So, sir, another question is on the Earth tunnel. I think Mr. Manoj is asking if we put a 200 mm pipe in a 2 meter deep trench with an air blower attached to it, will it cool the room?
It will not.
It will not, yes.
Manojji, there are certain literature available, which it's called earth air tunnel systems.
Yes.
And earth air tunnel systems will tell you that the air temperature, or rather soil temperature below undisturbed soil, not something which is having foundation, undisturbed soil below 4.5 meter will have a same temperature across the year. So 2 meter deep, definitely not going to work. And when it is a trench,
yes,
it is all not, because trench means it's a disturbed soil.
Correct. Pankaj, you want to ask something? Huh? So I think, sir, another question, sir. Are you comfortable? You don't have class or something?
No.
Okay. So there is another question from Mr. Verma. Sir, if buildings are the third skin and truly climate responsive, then can they actually cool themselves when wet bulb temperature is 30 to 35 degrees Celsius? For example, if the outdoor means air surface temperature is 53 degrees Celsius, can such buildings maintain indoor conditions 25 degrees Celsius lower, say around 28 degrees Celsius, without fans, ACs, and with all windows and doors closed?
So, Tanishji, no. I mean, buildings cannot change the air temperature, nor it can change the humidity. So, what buildings can do? Buildings can do, number one, it can prevent. So if I have a 53 degree outside, I may not allow that 53 to come inside. But if 34 is inside, it will remain 34. So basically, number one, when you say third skin, it can protect you. Second is that it can delay the impact. For example, 53 degrees centigrade outside may take probably 2, 3, 4, 5 days to come in. But fortunately, since Earth is moving, we will have a lower temperature in the night. So what you can do is that your walls are protecting you from 53 degrees centigrade surface temperatures. But when nighttime surface temperature drops to 28, you open your windows and bring all that cool air inside. Next day morning, shut the windows and store the 28 for the rest of the day. That is possible. But changing a air temperature, in technical term we call it a changing psychometric chart. On psychometric chart, air cannot change its behavior because of the building envelope. It is possible to construct a wall like US or Germany country where there is a still of timber frame with the AAC and any other panel on exterior envelope and gypsum board interior still achieve require thermal. Say by filling. Yes, Saranji, it is possible, but I think India is a place where our diurnal temperature range, the heating and cooling, or rather high temperature and low temperature is so high that only insulation is not going to work. And what you're talking about is just insulation. As I was mentioning, we need a mass. We need a mass and insulation together to work. Okay, I think that's good. See, Amit ji, the possible lower U value, does it sometimes translate to better thermal behavior of the walls? What is the best combination of hot and arid climates of Ahmedabad? Can we skip insulation? So Amit ji, this is where I say that only construction doesn't make sense. If you have a very high very low U value wall, that means you have very good walls. But if you open a window in Ahmedabad, hot air will get in. So very calculated way of operating window also matters. And you must operate window because finally you need a carbon, you need to remove carbon dioxide, you need to bring in fresh air. So combination of wall construction and window construction together will help you in a hot and arid climate like Ahmedabad. Only thick walls will not help, or only good U value will not help. And that's where the architects are there to help everybody. Otherwise, it will be machine who will be helping us to design buildings, right? Shall we close, Shailesh? You're on mute.
Pankaj would like to ask one question, sir. Pankaj.
Sir, one thing was coming to my mind. We were discussing the MAY-U construction, and MAY-U construction is one of the most extensively used technology in India for a decade or so as compared to other technologies. So many people come and ask that, okay, this thermal issue is there, but what do you suggest is the most suitable solution for the insulation of these walls as of now? What are the options available, and right now should we go for the paint or anything else we can do for them?
I think MAY-U construction, existing stock of MAY-U construction must get retrofitted by insulation.
Okay.
That's what I feel. See, it's a Shailesh, I sometimes people say MAY-U is bad, MAY-U is too hot and all. And what's our priority as a country? My priority is to put people in the houses. Now, I cannot have ideal houses on day one. Okay. It's always a change. So on first day, I have put people into the houses. When my economy is stable, when people start paying tax, I can spend some more money. The next day, I will go and give them an insulation. So it's always a priority which we need to. Everything cannot happen on a single day.
Okay. So I think, sir, that's all from us. Thank you very much. I think it's very educative and enlightening lecture. We look forward of your collaboration and association in near future as well. Thank you very much, sir, for giving us time. And on behalf of everyone present here, all the participants, we thank you profusely for dispelling so many doubts about thermal comfort and other aspects with regard to thermal comfort. With this, we come to the end, and I request everyone to please switch on your cameras so that we can take a virtual group photograph. All of you are requested to switch on your cameras, and yes, the entire lecture will be available on our YouTube channel. You will get the link of the recording as well. So please switch on your mic, switch on your cameras so that we can take a photograph. Okay. So I'll count 1, 2, 3, and then we'll take a photograph. 1, 2, 3. That's all. Okay. One more out. Thank you, sir. Thank you, sir.
Thank you.
Okay.
Thank you.
Thank you. Thank you, one and all. Thank you. We look forward to meet you again.
Thank you, sir.
Thank you. Thank you. Thank you. Thank you. Thank you.